And then there's another myth that blockchain is not secure. Yeah? And to understand this, we need to discuss what secure really means. Secure means safe in the sense of trustworthy and running at a high level of availability. And secure also means encrypted or authenticated, or with using non-repudiation mechanisms when exchanging data between participants. And blockchain is unsecure if people talk about Bitcoin and the application level of Bitcoin. We have the blockchain technology underneath, in the case of Bitcoin as well, which applies to all cryptocurrencies and anyway to all B2B blockchain technologies. But in the case of Bitcoin, of course, we have the application of cryptocurrency on top of that. And we have several organizational layers on top of that again, which are exchanges, for example, or just users and usages of Bitcoin. And here at the top layer, there we have an issue. Yeah? There exchanges are attacked and private keys are stolen and Bitcoins are stolen. Yeah? Hundreds of thousands of Bitcoins worth millions to hundreds of millions of euro. Yeah? That is unsecure. And it's also not very convenient if I do a Bitcoin transaction, because I need to enter a bits and bytes code, and if I do any mistake, my transfer of value goes into nirvana. Yeah? So, but it won't reach my actual addressee of the transaction. So that is also not very secure. That's true, but that is the application level. Technically speaking, it is very secure. Yeah? So nearly 10 years ago, on the 3rd of January 2009, Bitcoin has been started by Satoshi Nakamoto, and since then it was running without any interruption. Yes, there were hard forks, and yes, there was a lot of discussion in the community of Bitcoin developers and Bitcoin users, but the technology was just running without any interruption at 100% availability. And if you ask an IT guy, can you offer me 100% availability? He would always say, at least when it is about the contract, signing the contract, he will always say, 100% is quite strong. Maybe 99.9, maybe 99.95, that is okay. But 100%, okay. But Bitcoin has been running for 10 years at 100% availability. And that is a very strong value, yeah? If you consider designing distributed systems and distributed applications. So it is secure and it is safe at the technical layer, but there's another myth. And the blockchain is secure. So this is a German relict. The blockchain is secure. That is exactly the opposite again. Yeah? So there are other people who say, blockchain is extremely secure. Yeah? So if you use blockchain, it's more secure than anything existing before. Well, it depends. Again, we need to go into the details. And it is more secure than other systems if all the other security requirements, which have been existing already before, are also addressed by the blockchain technology. And what does that mean? It must be secure against cyber attacks, for example. If I deploy a node somewhere in the cloud, it can be attacked. Yeah? So I need a firewall, and I need a lot of technology to make this node safe or secure against cyber attacks. There are nodes which are distributed across organizations even. Yeah? So they need to talk to each other. We need a communication channel between these nodes from organization X here to organization Y over here. And we need a secure channel. So we need authentication between the two organizations and between the two nodes. So we need electronic signatures to authentify that a message coming from X to Y is really coming from X and not from anyone else. We need a secure communication channel in the sense of encryption, such that no third party can read the data that is exchanged. We need to apply this technology to avoid man-in-the-middle attacks, that no one no third party jumps in the middle and pretends to be Y vis-a-vis X or X vis-a-vis Y. These are classical security requirements, and security measures exist to mitigate that. If we apply all this to the technical stack of the blockchain communication between the nodes, fine. Then it is secure up to the state of the art today. And only if that is applied, blockchain adds another layer of security. And that additional layer is Byzantine fault tolerance, which means that if we have a classical system, which might be a database, which is replicated, and then again geo-redundant with a separate compute center 10 kilometers away, we still have one application. And if a cyber attack succeeds and is able to penetrate this application and to change the data, we just have, logically speaking, one location of data, and that can be attacked. In the case of blockchain, we have several locations. We have the validator nodes, which might be usually 7 or 10 or more. And if we have a cyber attack here, it is just one of the nodes. And even in the very worst case that data is changed and data is corrupted, and even the behavior of this node is corrupted, such that this node doesn't behave correctly anymore when a consensus is done between the different nodes of the blockchain, the others will just ignore that. Because consensus means, in case of PBFT, for example, that a 2/3 majority is required for a consensus. So let's say we have 7 nodes. One is the proposer, who asks the remaining 6 nodes, this is my proposal for the new block. What is your opinion about this? Would you confirm this block, or would you tell me that this is a wrong block? And or would you just misbehave as a data communication entity in this round? And then he sends out the block to the remaining 6, and out of the 6, 5 respond with an okay, because they work well, they are not attacked. But there is number 6, which is attacked, and that misbehaves. That says no, or it doesn't say anything, or it says something wrong. Yeah? And for the proposer, a 2/3 majority is still given. Yeah? And even if there are 2 nodes attacked in this group, it is still possible to achieve a 2/3 majority from the non-attacked, from the existing other nodes, from the validators. Only if 3 are attacked out of the 7 altogether, we don't have the 2/3 majority anymore. And yes, in that case, the cyber attack is successful. But it would require to attack 3 organizations in parallel at the same time, and that is very unlikely, today at least. Yeah? So in that sense, by adding this redundancy, by adding this Byzantine fault tolerance, we have an additional security layer compared with classical distributed systems. Only then a blockchain is more secure than other systems.